In this video, you learn 5 tips and tricks to write better functions in Go. Each tip will have a bad example and it will also have a good example on how to do it. Let's say you're building a social media app and the user need a way to upload photos, and these photos need to be validated, resized, watermarked and stored. Here we can see we have a function called upload photo. Then you can imagine inside this function we want to do some validation. So we will start checking if the format is okay. If not, we will return an error. And after that, we want to check if the photo has the correct size, and we want to decode it. And in case something happened, we will return an error. The next thing we want to check is, after we decoded, is there any errors? If no error, we can prepare for uploading. You can already see now that this code is getting very nested and getting quite hard to read. Let's continue. Next, we check if there is an error. If no error, then we can finally upload it. So how can we improve the code in this function to make it more clear? What we can do is we can flip the condition and we can use something called early returns. Let's start with flipping the outer if statement. So if we do that, we can see we will do the check here instead. And if it's not a valid format, we just return the error right here. Next, we want to flip the file size condition. So if we do that, it will look like this. And same here, we just flip the condition and then we return an error here. And we can also do the same for when we're checking the error of the decoding. So as we see here, we check if there is an error and then we return it. If there is no error, we just continue. And then we can do the same thing for the if statement here. So we just check if there is an error, return, otherwise we just continue in the function. As you can see, by doing this, we don't have to write if else. We can just write the if statement, and if there is an error, we just return. So here you can see we're doing all the checks, and then if it's okay, we just continue with the function. When you write function, you want to avoid nesting if possible, because nesting makes it harder to understand and make the function more complicated than it has to be. The next tip is keep your function small and focused. So a function should do one thing and it should do it well. Let's see how the prepare for upload method could look like. If I remove this code, and then I will start creating the prepare for upload. So this function probably take like an image and this might return some result of the image and then maybe an error too. And inside here, maybe we want to resize the image. We also want to compress the image. We want to generate a thumbnail. We want to add a watermark. And then at the end, we want to return the result. As you can see here, this function is doing a lot of things. And what if we want to reuse the logic for adding a watermark or maybe generating the thumbnail at other places? With the current code, that is not possible. So what we can do is we can start by splitting out these parts in the function to smaller functions. We can start here with the resize logic. I have now created a new function for that. That is called resize. And all it does is it resizes the image. And then we can move on to the next part. So here we have the create thumbnail. And again here, I just created a new function that all it does is will create a thumbnail of the image. And we can do the same for add watermark. I create a function that add a watermark to the image. And then I do the same for the compress logic. So I created a new function for that just compress the images. And I can use it here, and I can also use it here, both for the full image and for the thumbnail. As you can see now, this function is much easier to read and it's very easy to understand all the different parts inside. And another benefit is that small functions or methods, if you want to call it, They do only one thing, and we can now reuse them at other places if we want to. And the next tip is that you should always give your function descriptive names. And by just reading the function name, you should understand what the function does. So let's say we have this example is called update image. And then we have another one that is called check file. So let's start with the update image. Like, why is update image a bad name? Because when reading update image, you have no idea what that means. Like, what is it updating? Is it changing the color? Is it changing the width? Basically, it could be anything. So a better name for this image would probably be like resize to max width, because that's what this function does. It resizes the image to a max width. And then we have check file. And this name, again, is not a good naming because it's very unclear. What this function does is it takes a file and then it checks if that file is of any of these three extensions. A better name for this would probably be something like is supported format. Then by just reading it, I will understand, oh, okay, so this function just check if it's in the format that we want it to be. Let's move on to the next tip. And that is minimize function parameters. Function that takes a lot of parameters, they are difficult to work with because you need to remember the order of the parameter. You need to remember what all parameter does. And then you also need to remember which one are optional. There's no like rule that's saying that you can only have X amount of parameters. If possible, you should try to have less than 3 to 4 parameters, because basically after that, then the function just become very hard to work with. Let's start with our example here. We have this prepare for upload function again. And this time we want to be able to pass a lot of different settings for it. And as we can see here, there is a lot of parameters here. And it's very hard to keep track of them. Let's see how it will look like when we call it. It will look something like this. By reading it, I have no idea what parameters is what. So then I would have to go back to the function and look here. Okay, and this is the watermark and that is position. Let's see. As you can see, it's like a nightmare to work with. How can we solve this? The first thing we could do is we could create a struct that keeps all our settings to our photo. So here we have the parameters that we passed before to that function. And then let's see how the function will look like. It will look something like this. It will take the image that is going to prepare for the upload. And then we have the photo config that is a struct of the different settings. And when we call it, it will look something like this. So we say prepare for upload, we pass the image, and then we pass our photo config. And here is very clear what everything is. So we see, okay, this is the max width, this is the max height, and so on. Let's move on to the last tip, and that is make dependencies explicit. What does that mean? Functions that depend on global variables or hidden state, they are harder to write tests for. Here we have an example, and it's called save image. So what this does is it saves the image to S3. And in case you don't know what S3 is, it's a service that AWS offers. Basically, you can store files in their cloud. So what we're doing here, we're using a S3 client and we upload the file to AWS servers. Why is it bad doing like this? Imagine if we want to test this function. To test this one, we need to do a real upload to S3. And the reason that is bad is because it's slow, it needs to have internet access, and it can fail for reason that is not related to your code. For unit tests, you want them to be able to run as fast as possible, and they shouldn't be dependent of external sources. So how could we write this in a better way? The first thing we will do is create an interface. And by creating an interface, we can later swap out this upload method, because when we're testing it, we don't want to call the real S3. Then we will have a service, and this service will have a storage, and the storage need to have this upload function. The save photo belongs to the photo service, and instead of using a global variable, we're using the storage that is attached to this photo service, and we call the upload. This is how we would create the service. We pass the storage, so we pass our S3 client. This S3 client you would initialize somewhere in the code. It doesn't really matter. The important part here is for the photo service, you can swap the S3 client for anything as long as it have the upload function that take a path and take the data and then can return an error. And let's now see how it would look like if we would like to test this save photo. We will start by creating a fake storage struct, and then we will attach a upload function to it. And this upload function is matching with this interface. And then we could write the test. So we could say test save photo. And here we are creating our service. We're passing our fake storage, and we can then test the save photo method. When we're calling save photo, that is not giving any error, and that it contains the user ID that we passed. The benefit of doing like this is that we can test the logic that we have inside save photo, and we don't have to do a real upload to S3. We just want to test the logic of this function. And the reason we can do that is because photo service is accepting interface. And because of that, we can replace the S3 implementation with a fake storage instead. So these 5 tips: return early, keep function focused, use descriptive naming, minimize parameters, and make dependency explicit. If you follow these tips, your code will become easier to read, test, and to maintain. If you enjoyed the video, don't forget to like it and subscribe to the channel. See you in the next video.